Hey everyone, welcome back to my channel. So today we'll be learning about what are constants and about the ASCII encoding standard in C programming. So in C programming, constants are basically fixed values that the program cannot change during its execution. What I mean here is that a constant is a value that can only be read when a program is being executed. A program cannot write to that. Okay, so constants are only readable data. Now these constants are like variables, but as the name suggests, their value remains constant throughout the program. Now let me give an example. So let's say you like whenever we want to find out the area of a circle, right? We use the constant pi, which has a value of 3.14 blah blah blah. Okay, so this value is fixed. Now rather than defining it again and again throughout the program, and in order to make sure that this value is accessible throughout the program and it doesn't change, because we know that if the value of pi changes during the when a program is executing, it can cause a lot of issues and our calculations can come wrong. So we want to make sure that this value is defined as a constant and it never changes throughout the execution of the program. So how can we do this? It's very simple. The syntax for defining a constant is there are basically two ways which I'll be showing you here. The first way is by using the constant keyword. So I can write something like constant, okay, constant float pi equal to 3.14. Okay, so here I have defined a constant of data type float. Now I can use this value anywhere in my program to perform calculations such as calculating the area of a circle. Now, like I said, the constant keyword, what does it do? It ensures that the value remains unchanged. Now there are different types of constants. Whenever we are using the constant keyword, one advantage of using the constant keyword is that I can specify the data type. For example, if I define a constant integer value, that my variable can only take an integer constant. That is, it can only take an integer value, and that value cannot change to a floating point or any a character data type. Okay, so first of all, constants do not change at all. We cannot change the value of a constant during execution. And secondly, using the constant keyword, we can define constants based on the data type. For example, we have the four types of constant here. First is the integer constants. These are basically numbers without decimal points, like I explained in the previous lecture on data types. Then we have floating point constants, which take floating point values. Then we have character constants, which represent a single character, okay, enclosed in single quotes. One thing you have to remember here is characters are always enclosed in single quotes. That is a single character. And last we come to string constants. String constants are always enclosed in double quotes. Okay, now what is a string constant? A string constant is nothing but a sequence of characters. Okay, a sequence of characters. For example, we have the uh, string constant Jack in this case. Now what we are doing here is basically sequence of characters is nothing but a character array. Okay, character array. We'll be seeing that later in the chapter of strings, when we'll be covering that what are strings and how can we manipulate strings. Okay, so this is the first method using which we can define constants, that is using the constant keyword. Now let us come to the next method which we can also use to define a constant. Now this method is the define directive. Okay, the hashtag define directive. Now unlike the constant keyword, the hashtag define, it is a preprocessor directive. So preprocessor directive means what will it do here is that it will allow us to give a name to a value. For example, let us use the same example which we used for the constant keyword. I will use define hashtag define pi 3.14. So what will happen here is that anywhere in my program, wherever I mention the word pi, it will be replaced by this value, that is 3.14. Okay, this will be replaced by this value. Now what will happen here is that whenever I'm using the hashtag define keyword, what it will do here is that it will replace that value. Okay, and this replacement takes place before compilation. Okay, before compilation, this replacement takes place. Now, this is one advantage of the hashtag defined directive. Okay, but the only issue here is that whenever we are using the hashtag defined directive, it does not respect the data type. Okay, it doesn't see the data type. Basically, here we are giving a float value. We haven't mentioned a data type for the name pi. The only work it does here, it just simply replaces the text. Whereas if we use the constant keyword, it enforces the data type. It means that we have to use only float here in this case. Okay, in the example above. Whereas in this example, below example, what it does is we are giving a decimal value to the name pi, and this will be replaced in the program before compilation wherever I have mentioned. So let's try to understand this better by writing a program. Okay, so let's go ahead and write a simple program for this. Now the first program we'll be writing is using the constant keyword. So I will include my standard input output library to use the printf function. My main function will come here. Then now I will define, let's take example of three constants. Okay, an integer constant, a float constant, and a character constant. So first I'll define an integer constant. Sorry, max users equal to 100. Okay, then let's take a float constant. Let's take the value of pi, that is 3.14159. Then let's take a character constant. Okay, now let's print these values. And see what do we get. Here I will be printing the new line character. And here I will be printing the value of pi. Let's give it a precision of 0.5 up to 5 decimal places and the value of pi. Now if we go ahead and run this program after compiling it, what do we get is so let's run this program. So as you can see, we got our values, that is 100 and pi. Okay, and here what we have done, we have printed a new line character. That's so as you can see, the value of pi came on the new line. Okay, now what happens if we try to change the value of a constant? Let us see that. Okay, let us see what happens if we try to change the value of a constant. Now let's say pi is equal to 200. Okay, pi is equal to 200. Now as you can see, a compiler has thrown an error here. What is the error? The expression must be a modifiable value. It means a value that which we can modify. But like I told you, constants have only read access. We cannot change the value of a constant. Thus, it is not modifiable, and anytime we try to change the value of a constant in a program using a syntax like this, what will happen is my compiler will throw an error and I cannot compile the code. Okay, now let's do the same thing by using the hashtag define directive. Now rather than defining the constants here, what will I do is I will define them here. Okay, I'll say hashtag define pi 3.14159, hashtag define max users 100, hashtag define new line. Okay, that is a new line character. Now one good practice is that when I'm defining constants using the hashtag define directive, a good practice is to give the constants a name in uppercase. So try to use uppercase letters when defining constants using the define directive. Okay, so now let's see how we can print this value. It's very simple. I can just go ahead and directly print it. So printf value of just a second, let's not just type this entire thing again. I'll just replace the values here. Max users, here I will type the value new line, and here the value of pi. Let's go ahead and compile and run this program and see what do we get. Now our program is compiled, and as you can see, we got the same value. Okay, so this is how I can define constants using the two methods as we have seen. Now, which method is more useful? Now, it totally depends upon you, especially if you want to perform strict type checking. You want to make sure the constant is an integer constant. So in that case, you use the constant keyword. Else, you can use the hashtag define directive, which is clean and efficient. Now, let us come to the next topic of today, which is the ASCII table. Now, what is the ASCII table exactly? So, what ASCII table is basically, it is a type of character encoding. Now, whenever one thing about computers is that, as we saw in the first chapter, is that computers can only understand numbers. Okay, computers can only understand numbers, which in electronics these are signals. Okay, when it comes to electronics, these are signals, and they are represented by zeros and ones. Okay, these are numbers. Now, if we give a computer an alphabet like A or a name, okay, like Jack, what will happen is that the computer cannot understand this. The computing system cannot understand the human language. So what do we do here is we use something, a process called as encoding. Now, what does encoding or the ASCII encoding do is basically they assign a unique number to each character or symbol in a program. Okay, so for example, if we have the English alphabets from A to Z, in the ASCII table they will have a corresponding numerical value. So let's go ahead and see that. So what does ASCII do basically is it assigns a unique number to each character or symbol, okay, in the English alphabet. Now the full form for ASCII is American Standard Code for Information Interchange, and it is a system for representing characters as numbers that computers can understand. Like I told you, computers can only understand numbers. Now there are several other encoding standards such as UTF-8, UTF-16. UTF-16 is widely used in the Windows operating system. We will see that we will learn about Windows operating system in our next playlist, which will be about Windows API programming. That will take some time. First, let us master C. Okay. So coming back, let's not go away from our topic. So coming back, let us have a look at the ASCII table. Okay, so now as you can see, the ASCII table, which is the American Standard Code for Information Interchange, this encoding basically has it has 128 characters in total, ranging from 0 to 127. Okay, these are the numbers or the numerical values which will be given to these characters. For example, let's see where the value A is. Okay, so as we can see, the value A in the ASCII table, okay, has the number 65. Okay, it takes the number 65. That is, if we define a variable, let's say char variable A. So if we give this value A, what is happening is the computer doesn't see this as A. It basically sees this as the number 65. That is the numerical value of it. Okay, so this is how computers understand alphabets and the human language. Let's say we want to there is also a corresponding number encoding for the lowercase a, that is 97. Similarly, for digits also we have encoding. For 0 we have the value 48, for 1 we have the value 49, and even for space we have the value 32, and many other symbols which we use in a program. So this is how whatever you type on the keyboard, the computer is able to understand it. Okay, now let us see this with the example of a program. Okay, so what I will do is, let us print the value for A. Let's go ahead and do that, or many other characters. Let's try that. So let's say I define a character char ch equal to A. Okay, and let's print the value of A. Okay, print f Oh, sorry, I forgot a semicolon. Character A, here will print the value. Here will actually, now see, when we are printing the value, make sure about the format specifier. In this case, we have given the format specifier C. So if we print the value CH, it will print the value A. Okay, that is the human readable value. And if we want to print the ASCII value, like I said, ASCII in this case will be a decimal number. So we will be using the integer format specifier, that is %D. Okay, now let's go ahead and print this. We'll print the ASCII value and this. Similarly, let us print the ASCII value for space. Okay, let us print the ASCII value for space. Okay, let's go ahead let's compile this program. And now if we run it, we can see the ASCII value for A is 65. Let's verify this. Okay, ASCII value for A is 65, yes. And similarly, the ASCII value for space is 32. Okay, space is 32. So that's all for today. I hope you liked it and you understood about the concepts of constants and the ASCII encoding in C. Till then, see, goodbye, take care, and see you in the next lecture.